Welcome to the second of our Sustainability Stories event. I am Tim Frey and I work for Loven Patents and Trademarks. Some of the feedback we had from the last event was it was not entirely clear why we're doing this as a patent and trademark firm, and I thought I would just have a single slide just to explain that. We are responsible for our planet, and Loven believes that everybody has a responsibility to the planet, and therefore sustainability is a key directive for us. This forum gives us the opportunity for some shared learnings and to share some lessons from entrepreneurs that have made green choices. And it provides a platform for discussion, so it can provide a basis for which we can all talk about sustainability and talk about green issues. I believe that sustainability should be an agenda for everybody, but there we are. That's the why. Let's move swiftly on to the presenters. I'm very happy to welcome today Professor Simon Pearson from the University of Lincoln. We have James Napier from CBN Expert and Graham Bonwick from AgriFood X Limited. So, Simon, if we can move swiftly on to you. I'm just going to get your slides up.
Okay. Thanks, Tim.
And away you go.
All right, thanks, Tim. Yeah, it's and thanks for tuning in, everybody. It's a great opportunity just to sort of talk about some of the work we're doing, and I wholeheartedly agree with Tim. I don't think there's anything more important at the moment in terms of just making sure everything that we do, all our actions are sustainable, not least in agriculture. So what I'm going to do over the next 10 minutes is just a real whiz through the sort of things that we're doing in my institute, LIAT, and then hopefully it might sort of sow some seeds of some ideas for anyone who's listening and who wants to get involved and take part in the journey. I'm sure lots of us are already on it already. But I just wanted to emphasise, so why is it important? And when I think about agriculture, I usually think around agri-food. I think of the whole supply chain, so from food to consumer. And there's a really good paper in Nature Food in January 2020, which showed that 21 to 37% of all global greenhouse gas emissions are from the agri-food chain. So it's absolutely vast, 13.7 billion tonnes of CO2 equivalents emitted in the food production and its supply chain. So there's no doubt if we want to deal with global warming and climate change, we've got to deal with emissions in the agri-food sector. The rest, you could decarbonise the rest of the world, but you're not going to meet really challenging emission targets without dealing with agriculture. Of course, it's really difficult because a lot of those emissions are biologically driven. So respiration of carbon dioxide from soils, from peat particularly, it's hard to deal with. Methane emissions from animals, again, hard to deal with if you take the assumption that that is an eligible emission. So really challenging problems that we've got to deal with. But why have we got to deal with them? And next slide, please, Tim. Oh, sorry, yeah. So this just shows our just a highlight of where we operate. So we operate out of Rhizome campus. Bottom right picture is the old hall at Rhizome, which is our head office. Bottom left is the Rhizome campus, and then the centre is just, we're in the middle of Lincolnshire, which is a fantastic place to do agriculture as a whole. So next slide, please. So why we've got to deal with, there's a video there, Tim. I don't know if you could click on that.
Not sure that'll work. I'm not sure that will work because I'm not sure we've downloaded the background to it. But if I
okay, all right, yeah. So okay. So normally it's a video, just shows just some of the problems that we've got. So agriculture's got to change, no doubt about it. We've got in a situation where we've got very high mass equipment. which is causing compaction, damage to soils. So it's very productive, yeah, get that, absolutely. But is that production method sustainable with the technologies we've got at the moment? And also, you know, we've got this climate change. You see that tractor there bogged down in mud. So that's just an example of operating in very wet conditions, which is ridiculous. But then you've got the converse of operating in very dry conditions. So climate is getting very variable. Next slide, please, Tim. And this just sort of shows some of the extent of the problem. And I just want to show this thing. So the lines to look out here are it's the black line with the crosses, and that just shows the Rothamsted wheat yields going back to the late 1970s. They've got amazing data set going back to 1850 odd. We just want to show the last few years, and this is the same variety planted on the same crop, so very reproducible experiment. But just look at the variation now in the wheat yields from 2008 onwards. That black line, it's bouncing up and down. Yields becoming very variable. So we're getting the extremes of high yields. That's a function of weather through the crop cycle for various reasons. But we're also seeing some very, very low yields. So look at 2012 dropping down. And I think if we put 2019, 2020 on, there's some other horrors in that story. A lot of that story is around climate change. So climate's becoming very unpredictable, and so is agriculture. So next slide, please. So how do we change? So agriculture's got to change. That's our hypothesis. Innovation's going to be key, and I just want to reflect on where innovation's taken us from, so that we got an understanding of where it's going to. So just for everybody there, there's 2 agricultural revolutions already. First agricultural revolution's horsepower, and you see that one that's an 1820 patent, which Tim didn't do, but the patent requirement probably hasn't changed much since then, Tim. And it's a single horse-drawn steerage hoe. Steerage hoe is exactly the same as you'll see on a tractor today, just that you haven't got a horse. Then you've got an 1820. You've got a steerage hoe on a track. So around the war, you've got a single. You've got a tractor unit with 2 people on it on a steerage hoe, and so you've got not a lot of change going on over 150 odd years, but change is accelerating. And next slide, please. Then you've got the third agricultural revolution, which was around pesticides. So 2,4-D patented in the war. And you've got then the plant breeding, fertilizers coming on stream. So that's the third agricultural revolution, and that really took us up to, I guess, around 2010, 2015. So quite recently. My question is you've got climate change, but are we at the end of the road for the third agricultural revolution? So you've got pesticides there, you've got glyphosate going, you've got, so you've not only got climate change, you've got to deal with environmental pollution, synthetic chemicals, all sorts of complex challenges that agriculture, again, it's got to change. So what is going to drive change? What is the fourth agriculture? What are we trying to do? So next slide, please. Tim, come on to the next slide, please. Yeah, and again. Oh, okay, and again. So what we're really focusing in is on robotics. So what's driving change? The fourth agricultural revolution, and that's really coming at us at extraordinary pace. And just want to show you the pace. So we're working very, very actively now on all sorts of new robotic systems. We're working on 3 forms of robotic systems. One, robots for selective harvesting of crops. So robots which can go out into farms, pick fruit and vegetable completely robotically. We're looking at robots for phenotyping, so selective breeding crops. And then the third big strand is things like weeding robotic platforms, and so we're seeing a whole new generation of technologies, And I just want to show where this has come from. So the first one was invented in 1996 by Till and Haig at Silso Research Institute. And that's a camera-driven robot where the camera is identifying the row, basically the crop row, so that the tool can hoe between the row. And that's gone from 1996 to 2020, the Garford Robo Weeder. And that's using the same imaging technology. So you see the camera on the front there, and it's identifying where the row is, and then the hoe there is actually hoeing around the crops. That's robotics. These things are actually coming at huge pace, and what we're now trying to do is a next generation of hoe using artificial intelligence. So we can not only now identify the row, but we can identify the weed, and we can do that in real time. And we're layering that on now with really advanced computation using artificial intelligence for image recognition, high-speed actuators. We're using 5G to move data around farms, incredibly high bandwidth and low latencies. So these technologies are developing at incredible speed, and they're powered by AI. And these are the technologies which we think are going to drive the future of farming. If we go back 2 slides, please, Tim. So robotics are coming. That's, yeah.
About a minute left, Simon.
Okay, go forward one then, please, Tim. So these are digitally driven technologies, and they can be used across the space in multiple uses, really to achieve net zero. So we can use data to connect supply chains in the digital economy. So we can use it to efficiently optimize supply chains to reduce waste in supply chains. We've got new sensors, which we can use to inform better decisions. We've got things like energy systems to connect data together, et cetera, et cetera. So data-driven technologies are transforming agriculture. They're going to help for net zero, and robotics and AI will be at the very heart of it. That's the work we're doing at Lincoln. So with that, I'll end there. So
thank you very much. Thank you very much, Simon. That's brilliant. I think we'll move straight on to James now, who's going to tell you a little bit more, I think, about net zero, I believe. I'll stop sharing and hand straight over to James. You need to unmute yourself, James.
Yes, always fall foul to that occasionally. Again, hello everyone. Thanks very much for the opportunity. As Tim said, I'm the founder of Carbon Expert. We help businesses to measure, manage, reduce and report the carbon emissions in their business. And we are, as the top right says, a partner of the United Nations Race to Zero campaign. So we're currently helping companies diverse as law firms, car body repair shops, technical manufacturing, whiskey distillers, professional sports clubs to actually start the journey of measuring their carbon emissions and tracking all the way to net zero. So what I thought I'd take the 10 minutes to talk about, and forgive me if I'm telling people something they already know, but really is kind of a little bit about first principles of what net zero is, how it's come about, what it means and why it's important. So net zero really arose in 2015 when the Paris Agreement came into place. That was COP21. COP26 was delayed a year because of COVID and is this November in Glasgow. But essentially the world committed to reduce global temperature rises by 1.5 degrees by 2100. And to do that, it means that the world needs to be net zero. So whether that's mitigated emissions or offset emissions by 2050. And to put it into some context, there's a report that suggests that for every 1 degree rise in global temperatures, it will displace about 1 billion people. And that's largely because it's too hot or to live where they currently live, or where they currently live will be underwater. So it's a very important agreement. It was the first one that China stayed in when the US pulled out. Thankfully, the US has come back in now. And then what happens is each signatory country sets nationally defined contributions, and these are then supported by legislation to ensure that those economies are tracking towards net zero in line with the science-based targets. And what we did, we were one of the first countries to do it. In June 2019, the UK government made it legally binding for the entire UK economy to be net zero by 2050. So just very quickly on the timeline, it started with Paris. The end of the 5-year planning cycle is COP26 in Glasgow this year. The outcome of that is expected to be global carbon pricing, so global carbon tax. So the entire world committing to charge polluters for every ton of pollutant that they emit. The Race to Zero was launched last June, is about a year old now, and that will be an initiative that underpins the whole of the transition. And then we hear a lot about science-based targets. So the interim target is a 50% reduction by 2050, and then net zero globally no later than 2050. But really importantly is if we don't hit the interim target, we can't hit the long-term target of 1.5 degrees, because the Earth needs all of that time to start coping and repairing itself because of the carbon emissions. So I guess the next question is, how are we doing? So headline is we're about 20% of the reduction that we needed. In context, the UK's first lockdown last March got us to our reduction, but we lost more than 95% of that as soon as the lockdown finished. And so we need about a 7.6% year-on-year reduction. That's a 5-fold increase from the reductions that we had in 2019. And then again, these targets have to be absolute reductions. They're not tree planting. They're actually the mitigation from things like renewable energy, from electric vehicles. And we really need to start now. The United Nations publishes an emissions gap report every year. In December 2019, that was saying that the committed actions was going to 3.2%. They've updated that with China saying 2060 and America now saying 2050 to it being 2.1%. But that's without any detail of how they're actually going to achieve that. So we've still got a significant task if we're going to do that. And then we talk about the difference between mitigation and offsetting. So in the first decade to 2030, we've got about a 50% mitigation in emissions, and then for the next 20 years, another 30% target, and then the rest is offset. So there will be things currently like air travel that are hard to abate, have no technical solution. We'll get technical solutions that will help that, but ultimately what we've got to look to do is to reduce emissions that we currently emit by 80%. And that's a combination of lower emission technology, but also lower consumption. It is consumption, and especially the waste from overconsumption, that causes a lot of the problems. So where we come to target scopes, they're in 3 groups. Scope 1, 2 and 3, very handily called. Scope 1 is the emissions that a business generates internally, so from the buildings, from the transport that you own. Scope 2 is all of the emissions from the energy that you buy into your business, and those are relatively straightforward, relatively within the control of companies. And then Scope 3 gets very complicated very quickly. Upstream Scope 3 is all of the carbon emissions embedded in everything that I buy, and downstream is all of the carbon emissions that are emitted as a result of everything that I sell. So we focus on getting people started on 1 and 2, and then Scope 3 is something that is ultimately a complex but collaborative solution. And then just to put it into context, Formula 1's Scope 1 and 2 emissions are 250,000 tonnes, and they've calculated their Scope 3 emissions as 1.65 million. So Scope 3 are really the hardest nut to crack and form the bulk of emissions in companies. Really good. So why is it important? It's increasingly important to the customers of business. So anything that's important to your customers should be important to you. It's really important to employees, especially businesses employing young people. it takes real cost out of your business. At the heart of sustainability is efficiency. Use less, waste less, and so more efficient businesses are lower cost businesses. And if we have to have a 50% reduction by 2030, it means that we have to start now. So just a couple of things on that. So these are some of the companies that have made declarations to be net zero. We've had one of our users who's a tier 2 supplier to Jaguar Land Rover being told that if they're not net zero, significantly towards net zero, have a commitment when they will be net zero and a plan to get there by 2025, they will no longer be eligible to be a supplier to Jaguar Land Rover. So being net zero, being on the journey to net zero, very quickly starts to become a requirement to do business, especially if you sit in the supply chain of a larger company. Younger people, I say 85% of people feel unengaged at work, and a lot of that is we're finding is the social purpose of the business. But especially with young people, about a quarter of the workforce last year was Generation Z. Virtually all of those see sustainability as important, and we see that equally with diversity and equality. And then we're starting to see a lot of employers now realizing that being sustainable is critical to both employee recruitment and retention. And then really costs is two things. One is cost reduction. So if your business is more efficient because you're focusing on using less and wasting less, it takes real cost out of your business. And then carbon pricing is due to come in after COP26. It's about 24, 25 euros a tonne. It is predicted to go up to 45 euros a tonne in 3 years' time. And then there are some forecasts of it going over 100 euros a tonne in the future. So the more that you have to offset by paying the tax, the greater the cost that's embedded in your business.
It also left, James.
And that's it. Done.
Oh, perfect. Sorry.
So thank you very much for listening. A quick canter through.
Brilliant. Oh, that's really good. Thank you very much. Let's move straight on to Graham in the interests of time. Thank you. So now it's Graham from AgriFood.
Okay. Hopefully you can all see this okay. So hello, my name is Graham Bonwick from AgriFood, and I'm going to talk a little bit about some alternatives to current agricultural plastics. This is something that we're kind of focused on. So just a bit of background on AgriFood. We're a small startup. We've been going just over 18 months, and it was co-founded by myself and my colleague, Catherine Birch. But we're slowly expanding, and our sort of range of expertise is also growing as well. And so our recent addition is Roxana Milescu, who brings with her expertise around sort of green chemistry and novel solvents. We have a range of backgrounds which stretch chemistry across the food and also functional foods, food safety, those sorts of areas. So in terms of agricultural plastics, this is quite a considerable area of interest for us. Plastic usage is large, 18.5 million tonnes per year, of which about 40% is flexibles. And these are used for everything ranging from packaging to things like silage wrap, but also increasingly mulch films or weed suppression membranes. And these markets are quite substantial. Flexible plastics is estimated to be worth about $10.6 billion per year. And within that, mulch films alone are considered to be worth around about $4.3 billion a year. And that's growing at a healthy rate of about 6.4% per annum. Within the EU, the market itself is worth about €1 billion, and again growing as well. But it's actually in the Asia and Pacific regions that the growth is even more substantial and expected to grow even faster. There's a lot of interest in the use of mulch films because again, it potentially can minimize the use or reduce the use of things like pesticides or herbicides. The plastics themselves, though, are an issue. Particularly at end of life, there's an associated time and cost of their collection. but there's also issues linked to their breakdown and degradation, so leaving persistent residues in the soil, degrading to sort of micro and also now nanoplastics, which contaminate soil and water. And in Nature last year, there was a paper published which showed the first evidence of plant growth impairment as a result of uptake of microplastics. Also, there's potential for contamination of the food chain if there's any persistent chemicals associated with these materials as they degrade being released. They often get burnt at the end of life, though, unfortunately, and that's not only illegal but causes air pollution. And it is possible to recycle these, and there are companies offering this service, but it is made more difficult if they are contaminated with soil and things like pesticides. And there's also an incoming UK plastic tax, which will raise the price of oil-based plastics, such as polyethylene, used for these sorts of materials. So those are some of the sort of issues associated with this, and clearly something, perhaps an alternative needs to be found, which is more sustainable. And this is really what we as a business have been sort of looking at, is the potential to create more sustainable non-oil-based solutions. And we've particularly focused on the exploitation of agri-food byproducts. There's about 100 million tons of biomass produced in Europe alone each year, which is sort of ripe for exploitation. And this is possible. It is possible to extract not only valuable bioproducts, valuable materials from these wastes, and use those for various applications, such as food ingredients or even therapeutic applications. But what we're particularly interested in as well is turning these into a resource such as a flexible film. And we've had some success in generating a range of materials based on the exploitation of these waste biomaterials. And this is again consistent with the Green Deal. This is a direction in which we're expected to move, and it also reinforces the idea of a circular economy as well. So we've been successful in obtaining funding to support some of this work as well. And as part of this, we've been undertaking a project to try and understand better what are the requirements for these sorts of materials. It's all very well us saying, okay, we need a sustainable alternative, but there's more to it than that. If we want a product to be accepted, it needs really to be accepted by not just the end user, but also the supply chain in general. We're very pleased that there is a lot of interest in this area, but we still feel that there's a lot of work to be done before a product can actually get finally to market. So one of the things we've done is that we've explored the value chain. And yes, there's a lot of waste out there, but one of the things we've learned is that its distribution and also its availability is quite variable. And that's an issue if we're looking to sort of mass produce these sorts of materials. It is a source of revenue, potentially for farmers. They can be selling their waste. And certainly in, say, food industries, instead of having materials taken to landfill or even transported to AD, if somebody else is paying for its collection and transport, that may save money. But we also need to make sure that whatever new materials are generated are fully consistent and compliant with the existing machinery that's out there as well. It has to be compatible with manufacturing processes which exist already, ideally, and also the agricultural equipment that's used to deploy it. And again, end-of-life solutions, again, that needs to be compatible with the way that people want to make use of these materials. The other side of this, though, is that those same waste materials are a source of potential valuable high-value compounds as well. And that's another activity that kind of integrates with this. And so again, this reinforces the idea of sort of more integrated biorefineries being applied to those wastes. So we've also been trying to engage with end users to understand what are those needs. And this sort of human-centered design approach is something that we're very interested in. So the things we've learned so far as part of this journey is, firstly, probably as the most important thing of all, we must be cost competitive. We're up against, though, materials that are incredibly cheap, and imported materials as well are really quite cheap. And so that's quite challenging to try and compete on price or even match. These materials need to be fossil carbon free, but also they must lack persistent chemicals. We don't want materials being released into the soil at end of life or during their decomposition. One thing that's come back to us as well is that it's all very well saying that a material is compostable, but frequently materials are described as compostable but require industrial high temperature composting, which may not actually be readily accessible. And other information we've received is there's an interest from farmers in materials being able to be described as non-allergenic and animal-free, which we found really quite surprising. We didn't think that would be an issue at all, but we've heard that that's pressure coming from retailers. The other things that we've learned as part of this work is to realize that we've also realized that materials must be compliant with current international standards, and other sort of requests and requirements are compatibility with AD units, and that's actually an area which there's very little information. The final material, particularly for weed suppression membranes, it should be opaque. We've had people saying that more sustainable materials currently described as sustainable or more sustainable are often translucent, which doesn't really help by letting the light through, and actually enables plant or weed growth. People have been asking for grid lines to be printed so they can make holes in a regular pattern. And again, it must not impact on soil health. And again, as before, people have insisted that it's compatible with their current farm machinery. In terms of the human-centered design information, the feedback we've had says that these materials must weigh the same or even be lighter if possible. They'd like a film to have perforations so they can use short lengths of the materials. Distance markers, again, apparently is a requirement, and also indication of approaching an end of a roll. So these are some of the sort of human-centered features and information that we've received, which ideally we should incorporate into future products. So what are we doing? Our current status is that we're engaged in this interaction with farmers, but also manufacturers as well. We're undertaking a range of environmental testing, and also we hope to do trials with industrial production equipment fairly soon. We've been through a sort of a validation journey. We've been protecting our IP, and we aim for volume production of a product somewhere towards the end of next year. And as part of this, we need to achieve funding. Our aim in life is to actually partner with manufacturers, but rather, if that's not possible, plan B would be to construct our own manufacturing facility, which is clearly very expensive and less possible. So I'd just like to say thank you very much, and I'd like to acknowledge the KTN's or Innovate UK's funding of AgriFlex, from which some of this data has been obtained. And I'd also like to thank our partners at Grinnell University and also Queen's University as well for their input into this. Thank you.
Thank you very much, Graham. That was great. Looks like some interesting stuff going on there. I certainly didn't realise the requirements of retailers and the high specification requirements that they have for plastics. And I suppose now you can see that you know, if you want to advertise something as being vegetarian, you can't have some plastic which has had meat in its cycle at some point. Yeah, that puts a whole load of interesting areas on it. So we had a point from Bernard, I believe, which is talking about collaboration. And one of the things that comes up regularly here is to do with people working together. It was one of the points on my initial slides, is that you know, we need to get everybody working together on this, and we need to try and find some route to make everybody have their output so that they're interfaced with one another. And so this is a question to any of you, really. I mean, how do you see the best way to achieve that in the future? If any of you want to answer that question, feel free to go ahead.
Yeah, I think it's really crucial, particularly for early stage innovation, because you're up against, you might be up against, you know, where I'm at, you might be up against businesses with real scale, you know, John Deere, Agcos, those sorts of people who've got, you know, extraordinary resources and lots of people who can do things at, you know, not necessarily at pace, but they can do things at the early stage. You don't have that skill base usually, or you need to be pulling in skills, and that's about collaboration. It's absolutely crucial, particularly for early stage innovation. You know, you might have the kernel of the idea yourself, but you've got to work with other people to get it there usually. and that's collaboration with other people and funders. So it is possible. It's definitely possible. And then how do you get that collaboration? It's about networking. It's signing into webinars, going to events, meeting people, trusting people, and all those sorts of things.
Yeah,
it's essential.
Brilliant. Thank you. Thanks, Simon. There's a question here to, well, it's from Martin to everyone. It says, "Hi, Graham. Are you looking at rigid plastic waste as well in agriculture, drip tapes, etc.?"
No, we're purely focused on flexibles rather than rigid materials. But that is something we are thinking about because some of these biomaterials can be processed into fairly rigid materials. This is something we've only just started sort of looking at. There's some information in the literature as well about the use of byproducts to make sort of fairly rigid materials. So that's certainly something we're looking at, but it's not something we're involved in right now. But we are in discussion with another party about this.
Okay. Any more questions? Anyone else like to jump in? No? Okay. Well, that then we'll draw it to a close. Just the last thing to say is that we have another one of these events in 2 months' time, and we have Adam Banks, who's coming along from Instar Farming and is going to talk to us about insect farming and why insect protein is good to put into human food. If all of you, like me, wince at that very thought, then come along and listen to his talk. It's fantastic. So anyway, thank you very much to our speakers. Simon, James, Graham, thanks for your time, and thank you for everybody else for listening.